Yeah. Good morning, everyone. Am I audible, right? Yes. Well,
Yes, sir, audible.
and the screen also visible, right? Yeah. Okay. So, in continuation of previous class, so today we will discuss about major components in solar PV modules. So it's solar PV power plants. So, and this major part is solar PV module. If you see here, suppose one solar project is, if you consider a 100 rupees. So in that 60% value is solar PV module. So major equipment cost is solar PV module. It's almost 60% value in the entire solar project. And next to inverter or PCU. PCU means power conditioning unit. So for off-grid inverter, off-grid solar power plant, we called it as a PCU. So inverter or PCU cost is another 5% depends on brand. It will vary 5 to 10%, and rest all are in balance 30% you can get it. Module mounting structures and cables, distribution boxes, these all are okay. Today we will discuss about this one by one. First, solar PV modules. So here you can see module module provided will be solar silicon technology with crystalline silicon technology. The crystalline silicon modules have operational experience over 3 decades old ever, including in India. The solar module manufactured by one of the largest manufacturer of solar cells and modules have been principal. Modules are IEC certified, environment friendly, meet the requirements of safety. You see here, this is the typical solar drawing, cross-sectional drawing. You can see bottom side it's a P-type layer, depletion layer, or N-type layer. When sunlight hits the cell, it will start generate the electrons. So the electron flow will be like this. If you see on typical module, solar PV module. So here bottom side there is a back sheet, EVA sheet, encapsulate next EVA encapsulate sheet, ethylene vinyl acetate sheet. Next, solar cells. Solar cells arranged in this format. Next, again, encapsulation, EVA, ethyl vinyl acetate. After that, there is a glass, toughened glass. It is like our car windshield. So it won't break easily. So if you hit any hard particle, then only it will break. So it's a toughened glass and frame, anodized aluminum frame. It's aluminum frame. After that, they will do anodization coating. Uh, that coating will give the life of almost 30 years, more than 30 years for the PV module. If it is not anodized, then the rust will start at after 10 years, maybe if it is in a coastal area, maybe after 5 years, it can get the rusting out of frame. So once outer frame is damaged, entire module will also damage. And see here the types of PV modules. Polycrystalline module. I mean, right now in current Indian market and all over the world, these are the types of modules we are using. First, and widely what we are using, polycrystalline modules, and monocrystalline modules. These two are crystalline modules. So again, in this monocrystalline modules, there is a I mean, normal monocrystalline modules. Second one is bifacial monocrystalline modules. So yeah, yeah, so current earlier up to I think 2017, 2018, even 2020, up to 2020, all Indian manufacturers and all developers are using only polycrystalline modules. After that, in this monocrystalline modules are started using here the solar developers are using monocrystalline modules. Why? Because basically monocrystalline modules are higher efficient, but earlier whoever manufacturing the monocrystalline modules, they are manufacturing for only low temperatures. So like Germany, the US, though in those markets only monocrystalline modules are used. In those areas only monocrystalline modules are used because there you can get higher efficiency. Suppose if we use monocrystalline modules in India at that time, we cannot get that efficiency. We can get the efficiency equal to poly only. So then there is no use. If we are paying higher cost, monocrystalline modules are higher cost compared to poly. So if we pay higher prices, but it is not efficiency is not good means we cannot. I mean, there is no use if we use that mono. So that's why uh, earlier I mean Indian developers are not used monocrystalline modules. But after 2020, monocrystalline modules are giving higher efficiencies, even higher temperatures also, like Indian temperature. So again, the entire market is switching to monocrystalline modules. So now, at current now, all are in India, all are using monocrystalline modules. In that, two types are there: mono and bifacial. I mean, unifacial or bifacial. So both are using. Bifacial also, lot of people using. Bifacial modules means we can uh, compared to monofacial, bifacial modules, we can get more efficiency, almost to 5 to 10%. We can get the extra energy because backside it's a transparent, so we can get the generation from backside also. Bifacial means. So here you can see simple table for comparison. Efficiency rate now monocrystals are offering 22 or so 21, 20. I mean, all modules are above 20%. High efficiency rate, optimized for commercial use, high lifetime, and it is expensive. Polycrystallines are still at the 18% efficiency only. Slowly, it will. I mean, polycrystalline modules are slowly. Uh, it will very less now we are using. So the manufacturer will stop the polycrystalline modules completely and upcoming maybe another 2 3 years. So now at the time we will use only monocrystalline modules. Next, thin film module. This is a very low efficient modules. This application I will show where this we can use. And concentrated PV cells are very high efficiency, but very high price. And this for this maintenance is required. You can see to main concentrated PV cells, solar trackers is required, cooling system is required to get that efficiency. It is not, I mean, initial cost and maintenance cost will we can get more efficiency, but initial cost and maintenance cost will be more compared to mono. So that's why widely we are not using. You can see the difference between mono and poly. To make cells for monocrystalline panels, silicons formed into balls and cut into wafers. So this why these monocrystalline modules are giving higher efficiency means it will take a single silicon bars and they will make the cells. But polycrystalline modules, you can see fragments of silicons are melted together, form the wafers, and after that they cut into cells. So whatever the scrap, suppose after cutting this mono, there is any scrap material is there, like different sources we can get the this silicon from different areas. So all mixed together, they will mix and they will do this polycrystalline cells. But mono means it is not from one area, single silicon material they will use. You can see thin film cells. Thin film cells are like this. So it is flexible. So wherever the proper area is not available and you have a very large area. I mean, for thin film cells, if you want to set up a solar power plant, means you require uh, four times higher, four times higher space compared to mono or poly because its efficiency is 7%, 7 to 10%, I think. So suppose if you have very large area, then you can plan for thin film, but still, there is no use. Price-wise, little bit less compared to this mono and poly, but you require a very large area. So that's why this is also not using in manufacturers are not developing this type of cell and this type of module, and they are not. Developers also not using. You can see these are the concentrated PV cells. You can see here. Uh, So this is solar cell. On the above this, there is a one French lens. So when sunlight hits now, it is concentrated to one this cell point. So then we can get more light energy here. So that will connect to electricity. So this is the typical type of PV module of concentrated solar PV plant. So you can see how much thickness it is and how much setup is required. So these kind of PV models where they will use, why this is developed and where they will use means, suppose any for research purpose or for example, research purpose or army camps or somewhere very rural area, there is no power supply, there is no DG set access or something. So there they can use this kind of setup, concentrated PV cells. So why? Because they will in the small area they will get more efficient and more power, maybe for a shorter time. Maybe they will do some research at 3 months. They require a proper power supply, so they will use uh, this kind of concentrated PV cells. And another thing, in some areas in the world, maybe sunlight is available for only 3 hours, 4 hours. So there also they can use this kind of concentrated PV cells. That's why they developed, but it is not developed for a commercial regular market. You can see this is the typical PV module data sheet. For example, this is one PV module. Uh, so in each PV module, if you if you take one PV module datasheet, these are the parameters. Watt peak, maximum peak power. What WP means watt peak. So what is the maximum power we can get? That is the watt peak. After manufacturing this PV module, they will do a flash test. So in this flash test, suppose uh, one bunch of suppose one lot of PV modules manufactured. After manufacturing, they will do flash test. Suppose in that the value will be 360 above three, it will between 360 to 365. Even it is if it is coming 363, then that module is considered as a 360 watt peak module, and that parameters will be like this: mm, nominal power voltage means, and this is called a Vmpp, voltage at maximum power point, 36.7. If you see uh, voltage in this in PV module, there is a two types of voltages. One is VOC, open circuit voltage. Suppose if you are not connecting into strings, or if you are not connecting into uh, inverter, and it is not generating any power, then we can get that VOC value of 43.9. And if you when it is connected to inverter, modules are connected to inverter, and it is start generating power means that voltage is 36.7 Vmpp. And current also, IMP means when it is start generating, that is the maximum current we can get, or current at maximum power point, IMPP. And next, ISC, short circuit current. So if you short any PV module, maximum current we can get to 10.49. Like this, these are the respective VOC, VMP, IMP, ISC values of 360 watt, 365 watt, 370, 375 watt. Mm, And suppose if you uh, any PV module, suppose uh, two three company module data sheets if you received, and you want your company management, or suppose you are doing job at some place, or you are working for some other company, renewable energy company, or if you want to select for your own project. So to select a best module based on the data sheet, technically, commercially, there is a lot of other aspects are there, how the company bankability, and how that company big, how many groups are there, like that. This commercial evaluation is different. But for technical evaluation, you have to check. Uh, First thing is efficiency, module efficiency, which is higher. You can select that those modules efficiency wise. And second important one is these temperature ratings. Temperature ratings also you have to cross verify. Module manufacturer to manufacturer, make to make, and model to model. So it could, if you see here, nominal module operating temperature. So this is the module operating temperature, 44 degrees. Here they are offering. And next, coefficient of P max. Temperature coefficient of P max. This value you have to check. So this is minus, this should be very less. This is, they are offering minus 0.26, minus 0.26 percentage per degree per Celsius. That means uh, if you see this above values, here you can see various standard conditions. These above values are getting at STC. STC means standard temperature condition at 25 degrees. So when that this after manufacturing one module, the the manufacturer will test at these values they are getting at 25 degrees Celsius or not. So after 25 degrees, if 1 degree temperature increases, so this the power will reduce to minus 0.26%. If it is a 26 degree, 0.26% that power will drop. Got it? You got it? So if it is increasing per degree, so this 0.26%, 0.26% like that, it will reduce. So in typically in our India, in summer averagely we can get 45 degrees, 40, 40, 42, 40, above 40, right? So 40, let's consider 40 degrees. So 40 means it's 15, I mean 25 degrees, 40 degree minus 25 degree, 15 degree. So 15 into 0.26, 3.9, 3.9 percentage overall power drop percentage. So 3.9, for example, if you take 380 watt, take 380 into 3.9 percentage. So it will drop around 14 watts. So 380 minus 14, 366 watt only we can get at 40 degree temperature. That is also in, and when you get the maximum sunlight, 1000 watt per meter square, that also we don't get. We can get maximum of 600 watt per meter square like that, irradiation. And second one, what they are offering, these, first one is efficiency, and second one is temperature coefficient. Suppose some modules are offering minus 0.3%, then the temperature coefficient is very high, or some are offering minus 0.4 also. In Indian manufacturer, they are offering minus 0.36, minus 0.34, 4, like that. So then that modules are not efficient. So like that you have to select. If you have a 3, 4 option in that, which is the least one, that you can select. You can tell me your management or your this one to explain this. These are the factors we noticed. So technically, this is the best, and this is the second priority. And commercially, you can take your chance like that. You can give the offer, and warranty also you have to check. So warranty wise, uh, nowadays all are offering about 25 years, and 30 years also some people are offering. So here you can see any module manufacturer, first year degradation is very high. It is 2.5%. And after that, every year 0.6% will degrade. So like that, it is up. It will go to 27th year. They will offer minimum 80% you can get. This degradation also you have to check. Who are offering less degradation and more warranty? 30 years they are offering, or 25 years. Earlier it is standard 25 years. Now it is moving to 30 years. And you can see this is the typical module mounting. To design a module mounting structure, to place the modules in a module mounting structure, This drawing is required. This is the backside drawing. So these are the mounting pole pitch 1176 and another pitch of 1676, and overall module dimension is 1956 into 992, and this is the module thickness, and this is the horizontal pitch 956. So based on these details, we have to provide to module mounting structure designers. So they will design the structures suitable to our PV module. And you can see here these three types of PV module: poly, mono, thin film. Visually, we can easily identify which suppose uh, anywhere if you see solar plant, based on this visual inspection, you can tell this is the mono, this is the poly, this is the thin film. Next, I mean, suppose in the data sheet, if they offered in the data sheet, if they offered module efficiency, is that correct or not? If you want to check, so we have this formula, solar cell efficiency calculation. So here the efficiency max is equal to P max divided by E into A into 100%. So here the P max, maximum power in output, E incident radiation flux, uh, area of collector, A, AC means.